Have you ever wanted to hold a piece of perfect mathematical beauty right in your own hands? Well, today that's exactly what we're going to do. We are going to build our very own icosahedron right from scratch.
So, take a look at this thing. It looks pretty complex, right? It's this beautiful, intricate cage of lines and points, all perfectly connected. But what even is it? And more importantly, how in the world do you make one?
Well, this is an icosahedron. Now that's a fancy word, but it's part of a very special family of shapes called the Platonic solids. Think of them as the 5 perfect 3D shapes. They're totally symmetrical, and every single face is identical. And the icosahedron? It's the one built entirely from triangles.
Okay, so the definition might sound a little intimidating, but the secret to actually building this thing is, well, it's surprisingly simple. It really just comes down to its most basic parts.
That's it. This pile of plastic pieces is everything you need. Suddenly seems a lot more doable, doesn't it? That whole beautiful structure we just saw comes from nothing more than what you're looking at right here.
So let's break it down. There are only 2 types of parts we need to worry about. First, we've got these bright orange connectors. These are going to be our vertices, the corners of the shape. And then we have these simple gray struts, and those are the edges that will connect everything together. To build our icosahedron, we're going to need exactly 12 of these orange vertex pieces. Not 11, not 13, 12. That's the magic number.
And to connect those 12 vertices, you're going to need precisely 30 of the gray edge pieces. Now remember those numbers, 12 and 30? They're going to come back in a really cool way in just a bit.
All right, we've got our parts, we've got our numbers. Time for the fun part. Let's actually put this thing together.
So the first step is to just grab one of those orange vertices and connect 5 of the gray edges to it. You end up creating this sort of 5-sided pyramid, or maybe like a little cap. This little piece right here is the starting point for the entire structure.
Now, from that first cap, the whole process is kind of rinse and repeat. You just keep adding new vertices to the ends of those edges, and then you start connecting those new vertices to each other. You'll notice a pattern starts to show up almost immediately.
And what's really amazing is how the shape just naturally starts to curve and close in on itself. You're not forcing it into a ball or anything. The geometry of the parts is doing all the work for you, creating this elegant and surprisingly strong cage.
And just like that, with that last piece snapped into place, you're done. A perfect icosahedron built from a simple pile of parts. It's such a great feeling to hold it and see how all those simple little pieces came together to create something so intricate.
So, we built it. It feels solid, it looks fantastic, but how did we know that 12 vertices and 30 edges would work out so perfectly? Well, that's where a little bit of clever, simple math comes into play.
Yeah, this is the real question, isn't it? Was it just a lucky guess? Or is there some kind of fundamental rule that guarantees these pieces will fit together perfectly every single time? Well, as you probably guessed, it's all in the numbers.
Okay, check this out. This is the clever part. We start with our 12 vertices, right? Now, if you look at the model, you'll see that exactly 5 edges meet at every single vertex. So, simple multiplication, 12 times 5 gives you 60. But wait a minute, we only used 30 edges, so what's going on? Well, think about it. Every single edge connects 2 vertices, so when we did that first multiplication, we actually counted every single edge twice, once for each end. So to get the real number of edges, we just have to divide by 2. And 60 divided by 2 is 30, the exact number we needed. It works out perfectly.
And that just goes to show you, the math isn't some abstract formula you just memorize. It is literally embedded in the shape itself. That simple logic that every edge has 2 ends is the actual blueprint that makes this entire beautiful structure possible.
And all that perfect mathematical symmetry, it has a really fun physical payoff. The person who originally designed this model notes that because it's so perfectly balanced, once it's all put together, it spins incredibly well. It's basically a perfect little top.
So really, this model is way more than just a cool-looking object. It's a toy, it's a puzzle, and it's a doorway to some really deep concepts. And get this, hidden inside that web of edges are 3 perfectly balanced golden rectangles. It's just a fantastic, hands-on way to really explore geometry. All of which leaves us with one final thought. We just uncovered the simple logic hiding inside this one complex shape. And it kind of makes you wonder, doesn't it? What other elegant blueprints and hidden secrets are just waiting for us to find them, in all the ordinary shapes that are all around us every single day?